All right, so in this video, we're going to look at how we can map values to a Polars data frame based off of values in a dictionary. So let me get through the startup and then we'll kind of motivate this example or this discussion. So I'm going to import pandas as PD, import polars as PL, and I'm going to load in that store sales forecasting CSV to create both a pandas and a polars data frame. So that sales data PD is a pandas data frame, sales data PL is a polars data frame. So pandas, polars. All right, so let's look at the pandas data frame real quick. All right, so in this case, we've got, a data frame where we've got rows that are corresponding to specific products that were part of orders for some company, right? So we have information on, the categories, the product ID, all of the pricing information, the ship mode, customers, all of that. And let's take the ship mode. So what if we've got the order date and the ship date, and what if, depending on the ship mode, there's a different, essentially, promise on, how quick we will get things to a customer. So if they do same day, the difference between the order date and the ship date should be, very small, versus if it's second class or first class or standard class. And we wanted to actually compare the actual order versus ship date to see, well, given whatever our promise is based off of ship mode, did we actually meet that? All right, well, in this data frame, and we can't see all the columns, let's just look at that real quick. So sales data PD.columns. All right, we actually don't have any information about, okay, well, what was the promised, time between order and ship? So maybe we have that information and we just want to create a new column in our data frame which uses the values in the ship mode column and maps that across. All right, so first off, let's look at ship mode. All right, and I'm just going to get the unique values. All right, so we have a first class, standard class, second class, and same day. So let's say, I'm going to say mode, ship mode to days mapper. All right, so what if I have a dictionary and I'm going to have a key for each one of those possible values? So we'll do first class and same day here. All right, and let's say same day, it should be 1 or actually 0, should sit the same day. Let's say 2. If it's first class, if we give someone if someone purchases second class, we guarantee we'll ship it within 4 days. And if it's standard class, it's 7. Let's see, I don't have my dictionary defined correctly. I don't have a comma there. All right, now let's assume that we want to get these values into our two data frame objects based on the values in that ship mode column. All right, so everywhere second class, I want to have a value of 4 in this newly created comma or column. If it's standard class, it needs to be a 7. All right. Well, this is actually really, really easy to do in pandas. And this is something that, it might seem really simple. It's something I end up doing all of the time. It's amazing how many times I find a need to kind of do this. So very helpful thing to know how to do, at least in my opinion. So I'm going to do the ship mode. And I'm going to spell it correctly. All right, so if we get that column back as a series, what we can do is then we can call .map on that series, and we can provide that dictionary to do that mapping, right? So if I take .map off, we'll see the first 2 entries were second class, then we had 3 standard classes, we got a first class later on, but all it does is we're going to do a .map, and it's basically saying, okay, well, I'm looking up the keys in that dictionary must match values within that column, okay? And wherever it finds a match, it just puts in the corresponding value from that dictionary. All right, and let's look right here, like with second class. What if we didn't have an entry for second class? So what if I did not define that? Well, it's going to replace that with missing values. Now, that's one thing that's interesting, right? So notice that when I had second class in there, right, these are integers, right? Because every one of these are mapping at this point. So there's no value in that ship mode column that is not same day, first class, second class, or standard class. So they all map over. We get back integers because the things that are the values of our dictionary are all integers. But if we have any that are missing and it can't map, it says, well, I got to replace that. And it replaces that with not a number, right? Which is interpreted by pandas, or better yet, NumPy, which is kind of working under the hood, as a float. So that's why everything gets converted to a float. But still, there's a numeric types. Everything works out well. The real problem you might run into is what happens if it was a string that you were mapping. So let's just demo that as well. So right now we got integers. What if we were representing these as strings? So I don't know why we would ever do this, but this is just kind of representing a case where what if the thing you were mapping over are strings? All right, so it's now a type object because we've mapped over strings, right? If I were to get a .loc 0, that first thing is a 4, right? It's a string. All right, let's see what happens now if we were to take out second class. Yeah, this is actually subtly very weird, right? Because it looks fine, right? We got our 7. So if I were to do a .loc 2, all right, that's a string value, right? But what if I do a .loc 0? That's not a number, which if I do the type of that, that's a float. So you got to be careful. And this is one thing that pandas kind of allows, which I don't think polars will allow. I think it will complain to no end, and rightfully so, because what you've seen is now with this mapping, because one of the values wasn't there, depending on the row, I can have a string or I can have a float. So you've mixed types, not just ints and floats. You've got numeric versus string, and that can cause some interesting bugs. So you do need to be aware of that. And what we're going to see is polars ends up being quite picky about doing these type of operations, and I think it's because of this reason right here. Because if you're not careful, you can end up really mixing types, right? So now, but in the use cases that most times. There we go. And these would be integers. Let's just not do that right there. Let me get these all out. There we go. To me, that's really handy, right? So we've got this mapper, and then I could create a new column called, maybe this is going to be ship promise. And then there we go. All right. So now in our data frame, we've got that guy right out there at the end. So really handy thing to do. All right, let's look at how to do this in polars. And I said that polars is much pickier about this. And again, I think it is the right thing to do, right? Because they're forcing you to understand problems in your data. Whereas pandas allowed us to create a column right there where we had mixed types. Polars would, is not going to like that, and it's going to complain. It's going to force you when you're working with your data to kind of make sure that you're doing things correctly, right? Which I do think is helpful. It can be a little bit of a headache as you're trying to troubleshoot things, but ultimately, if it leads to us writing cleaner, more bug-free code, to me that's a win. All right, so we've got sales data PL. In this case, and what we want to do is we want to again map that over. All right, whenever we're doing changes on a column polars, we're going to use with columns and their expression syntax. So PL call ship mode. All right, so right now that's just returning that column. First off, let's just try to see, can we just do a map just like pandas, cross our fingers and hope for the best? Well, that doesn't work. Well, actually, we do see that. Oh, actually, no. I had a comma right there. It should be a dot map, right? Yeah, and it has no attribute called map. Note, did you note when I had that comma right there? Map was green, so map is actually a reserved word in Python. So map is a defined operation that's built right into Python. Okay, so that's why it did that. But Polars expressions, we have no thing map. So let's take a quick little look. Let me get an incognito window up. Let's see if we can find in Polars documentation. So I'm going to go to Polars. And I'm going to go to the API for Python. All right, so we're going to have expressions. All right, and let's just see. So right now we are in expressions. And I think, is this literally a list of everything? That would be interesting. It might very well be. Yeah, seems to be. And we got a lot of examples here. I'm really kind of liking their documentation. This is pretty fantastic. Because I've been kind of digging into these. And again, you might want to for temporal things, because it does give you a little bit more information, like you got to use that DT accessor. But apparently for just expressions that can be used in various contexts, right? We could just look out at that expressions level. All right, so the ones that I want to look at are, all right, so we did see that we've got this map batches and map elements. I don't think those are what we're looking for. So, you know, it looks like there's, you know, it's kind of interesting for mapping elements of a series. I mean, it actually tells you right here, hey, this is going to be really slow. Only use if you can't implement your logic. So they're kind of pushing you away from using map elements anyway. What you should be looking for is replace and replace strict. And I'm going to hopefully talk about some of these differences. So let's look at this. All right, so first off, we've got replace. Okay, so this says replace the given values by different values of the same data type. Okay, so apparently in this case, you've got to, you know, if I'm calling, you know, on a particular column, you're saying, okay, well, I want to just replace specific values with another value, but it has to be of the same type. Okay, so you can use that here. And this is, you know, if you're using it on a string, you can also look at like a string replace, right? So in their example right here, they've got a data frame with a column A that has values 1, 2, 2, and 3. And they're saying create a column called replaced, which is taking column A and it's replacing 2 with 100. So you see that in fact that gets done right here. And apparently you can provide multiple replacements, right? So replace 2 with 100 and 3 right here with 200. All right. Or you can do a replace with a mapping like we just did, right? The key thing when you're using replace is it has to be data of the same type. So the thing you're replacing with has to be the same type of the thing that you've already got, right? So if you've got an int column, you've got to replace with int values. All right, so I'm just going to go to our notebook here. So let's just see what happens if we do replace. This shouldn't work. Why shouldn't it work? Well, it's currently in ship mode, right? It is strings, and we're saying do a replace with, you know, integers. All right, so that should, surprisingly, it didn't fail. Let's see what happens here. So I should be looking at that ship mode. Let me redefine that. Interesting, right? So it did the replacement, but it converted them all to strings. All right. So let's look at that documentation and let's see if we can understand that behavior just a little bit more. All right, so old, new, return dtype the data type of the resulting expression. So if it's set to none, the data type of the original column is preserved. So what it's doing is apparently, because, you know, apparently we can convert a string to, or an integer to a string, it just goes ahead and it changes that. I wonder if we could do a return dtype equals int. Return dtype, and let's say if I'm going to do a pl int maybe a 16-bit int, this is how we could specify that. Right, so that actually worked. Right, so it does say that this is going to be deprecated. Right, so this is, yeah, so apparently it's still allowing you to do this, but apparently in the future they're saying, hey, we're not going to allow you to do that anymore. It's going to keep the same type, and they're pointing you towards using replace strict instead to return, to set a return data type while replacing values. So they're pointing you towards replace strict. So this replace works for now. It will not work in the future. So what we're going to be looking at is replace strict. All right. Again, let's turn to our documentation. All right, so we have done replace. Let's look at this replace strict. All right, replace all values by different values. So value sequence of old values to replace. New values, I guess we can just provide a mapping and it will take care of both of those. You can say set values that were not replaced to this value. If no default is specified, an error is raised if values were not replaced. Okay, accepts expression inputs, and non-expression inputs are also passed as literals. And then we can change the return D type. And let's look at this. So the data type of the resulting expression, if set to none, the data type is determined automatically based on other inputs. All right. So let's first look at this in this implementation. So right now it's creating this ship mode. So let's change that and make a column called ship promise. And let's just get the head. All right. So now we're creating this ship promise, and that is an int 64. All right. So that's what we expected that to be. And again, let me just show you when we had that replace earlier, right? That was running, but it was making that a string because the column that we originally were operating on was a string. All right, so when we go to replace strict, that looks good. All right, so we're getting that int. It's basically computing that based off of what it's got right here. Now let's look at that case of what happens if we do not have an entry. So anything, we've got entries in this mapper for same day, first class, and standard class, but nothing for second class. So what's going to happen when it tries to do, when it sees a value of second class in that ship mode, and it can't map it because we're not going to have a mapper defined. All right, it's going to give you an error. So this is what Polars does. Remember, pandas, like in this case, I reran. Let me restart this just to show you. All right. So in this case, here's the pandas mapping. It's going to do this map, but there's no second class, right? So pandas is just going to say, okay, all is good. Right, but when we look at it, let me just grab that column. Right, we got some places that are missing, right? And pandas just kind of does that silently. All right. Polars, on the other hand, is going to complain, right? It's going to say, huh, you know what? It was an incomplete mapping specified. Okay. It says, hey, if you are okay with this. So first off, if you think all of your values should be mapping, you need to inspect the unique values in that column and see what's going on, right? So it's kind of, this is Polar saying, look, the mapping you supplied is not complete. Tell me what to do, right? And this is kind of Polar's ethos, right? I mean, instead of doing like pandas and kind of doing something that is reasonable, right? I'm not knocking pandas here. It's a reasonable assumption, but sometimes it can lead to some interesting maybe bugs later on, like in that case when we had strings and it would mix NAM with strings in that column, right? Polars, on the other hand, is going to say, I'm not going to deal with it. You tell me what you want me to do. All right. And it gave us a hint that we should look at the default. So it says, hey, set values that were not replaced to this value, right? So if nothing is returned, an error is raised. So let's see what we can do. Let's see if we can set a value for that. So let's say our default, I wonder what happens if we just do none. All right, can we go out here? Yeah, so it actually will put a proper null value in there, right? So I think that's handy, right? So still we've got an integer column. So in polars, a null value is not a float, which it actually is in NumPy, as we saw. It gives an MP, not a number, which turns out to be a floating point from Python's standpoint. So that's, you know, not necessarily maybe the best thing, but in this case, you've got a proper null value. It doesn't change the type of your column. So this is how you would achieve that with polar. So replace strict. If you don't have a complete mapping, you can say a default is equal to none or whatever else makes sense for your use case. And then go from there. All right, let's do what we like to do is just a little bit of a timing check. So let's make this back where we've got a complete mapping. This should be super, super quick in both, but I'm just interested to see. So here's our polars or a pandas implementation, sorry. And then let's do our polars implementation. All right, so in this case, it actually looks like the polars implementation loses out, right? So that's kind of the first time that we are seeing that. Right, so it's a little bit slower, and it could be for the extra checks that they're doing, right? They're looking to make sure that you replaced all. So in this case, we do see, even though it's not a huge difference, right? I mean, it is a difference, right? So we've been seeing huge speed ups with polars, but in this case, pandas actually has a little bit of a quicker implementation, although it seems like they might let some bugs slip through the cracks. All right, so that is how we map values based on other values in a particular column of a pandas or a polars data frame.